This will be the first of a two-part series on water and energy, and we'll talk about the second part during the webinar. But just by way of logistical instructions, we are planned for this webinar to be about an hour in length. Our presentation will be about 40 minutes or so, so that should give you lots of time for questions. If you are hearing my voice, as I mentioned, you have figured out the audio, which is two ways, either through your telephone separate from your computer or a computer microphone and speakers. We are muting this particular webinar phone line because we have found in the past that there's always a lot of background noise, and we would like to record this webinar and be able to post this on our website for those of you who were not able to make the presentation today. So the web phone line will be muted, and what we will ask you to do is to type in whatever questions you have. You can do that throughout the webinar, and then we will answer all the questions at the end of the webinar. If you want to know where that dialog box is, if you see the orange box in the upper right-hand corner of your screen with a white arrow, that white arrow, if you click through, it'll open up a dialog box where you can type in your questions near the bottom. And Jeffrey Hughes, on the call with us today, will be assembling all the questions, and we'll be doing the questions roughly in the order that they were received. So we're looking forward to having a discussion with you about all of these issues. And at this point, I think we should just go ahead and start. We're still assembling people, but most of you are here at this point. So we have for you today two speakers, myself from the Alliance for Water Efficiency, and I also want to introduce Lorraine White of GEI Consultants.
Hello everyone, this is Lorraine.
And Lorraine and I have split the presentation into pieces. I will give the background to start, and Lorraine, who was responsible for the project and the recommendations, will walk us through what the work was that was done. So just by way of simple background, all of you who are attending this webinar are attending it because you know the obvious. The obvious is that water and energy are linked. They're linked not only at the production side, but they're linked at the end-use side. And although we've known this intuitively for many years, we've not actively managed that interconnection the way we perhaps could. And part of that comes from a lack of distinct information about the benefits of that co-management. Water is needed for energy. This is a pie chart. By now it's pretty familiar to all of us. It comes from the latest U.S. Geological Survey report from 2005 on water withdrawals in the United States. So it's withdrawals, not consumptive use, but water withdrawals. And 49% of all water withdrawals in the United States in 2005 went for power plant cooling. So clearly, water is needed to produce energy, and a sizable amount, nearly half of the pie of total national withdrawal use is based on that need. But energy is also needed for water and wastewater distribution and treatment and end use by customers. And Lorraine, when she worked for the California Energy Commission, was responsible for a lot of work that documented that connection in great detail. It's groundbreaking work that is being replicated in states around the country, documenting what the actual values are of kilowatt hours per million gallons of water treated, delivered, used by the consumer, and then retreated for wastewater and then discharged. That whole cycle is a very energy intensive cycle. It can range from a low of 2,000 kilowatt hours per million gallons to a high of 20,000 kilowatt hours. Depends on where you are, depends on your system, your situation. It's a very local calculation. And up until recently, we just weren't focusing on what that electric demand was. And that's part of the discussions now in the Water and Energy Nexus. Our view at the Alliance for Water Efficiency is that we really care about this connection, and we care about collaborating with our energy partners on this topic. We know that efforts for energy efficiency and water efficiency have historically always been separate programs, separately funded, separately managed, separately reported. They're parallel, but they're separate. And we're realizing now that that's not very smart. We really need to do these programs together. And the second webinar in our series will talk a lot more about that. What are some of the best examples of ways those efforts have been better managed and better coordinated? We as an organization are very committed to improving joint management of these issues in a wide perspective of programs, policies, research, practices. And we know that there are many, many stakeholders who are involved in these as well, these issues as well. So one of the project partners that we've had is the AC Tripoli, American Council for an Energy Efficient Economy, and we've been very active with them for the past several years in a project which eventually you will hear in this webinar began with that collaboration effort. So we got some original funding from the Turner Foundation to do some collaborative work together. AWE representing the water side, ACEEE representing the energy side. And the purpose of the project was to identify what the major research, program, and policy needs were of the Water-Energy Nexus. And we wanted to do this not only for decision makers who were active in the field and managing programs, but funders of research and those that were actively interested in a progressive development of better management strategies and new technological developments. And mostly we wanted to make sure we were establishing a national long-term energy water community, a community of stakeholders such as yourselves who are on this webinar that are interested in joint analysis and research and management of these two important resources. So the first project brought a lot of stakeholders together. We had 54 individuals from 41 different water and energy organizations come to Washington, D.C. in December 2010 and identify what the missing gaps were, what were the pieces that we really needed to work on together. And there were 8 main themes that arose from this collaborative discussion, and there were detailed recommendations in these 8 themes. There are probably 52 or so recommendations that are contained in the report. And there were 5 priority areas for immediate action, and one of those priority areas was set up a work group to look at the water and energy research situation. So that's the topic of our webinar today. Another priority area was to inventory all of the best practices and good examples of program management on both the water and energy side that have existed so far and use them as templates, as examples, best practice examples for others to follow. And that will be the subject of our second webinar. So we published a report. We called it Blueprint for Action. We widely distributed it. It's been out now for a couple years, and it's posted on our website as well as on the ACEEE website. But this is the, from the report itself, this is the water and energy research recommendation that was contained within the report. Basically said we need to develop a comprehensive database on water embedded in energy and energy embedded in water. How much water does it take to produce energy? What's the value of that? And similarly, the energy that's embedded in water supply and wastewater treatment and delivery. So the bullets underneath here describe the recommendation in more detail. We need a consistent and comparable methodology for measuring the embedded water and energy, make sure we're all doing it the same way. We need to develop consistent water and energy factors that will drive programs, policy, and technology development and implementation. So the first step is, of course, inventorying what those all should be. We need to look at regional and state-by-state data. We have great data from California, but not great data from elsewhere. Unless there has been specific work done by an individual water utility or region, a lot of this local information largely doesn't exist. We need to develop credible national estimates based on all of this compiled local and regional data, and some kind of baseline of total energy use by water and wastewater utilities and water use by electric utilities. So these were all of the recommendations that were contained within the blueprint. And what we ended up doing was setting up a research work group to begin to tackle this very large assignment. Not all of the topic areas have been fully addressed as yet, but what we wanted to do, at least to start with, was inventory what work had already been undertaken on the embedded energy and water and energy issues, and assess what that current work is related to green infrastructure and water and energy efficiency. Pull out some lessons learned there. Look at where there were energy and water efficiency studies and research documents to take a look at what the priorities were for that research, and assess water-related energy consumption, and then recommend steps for national and regional research. So those were the goals that we had set out for the work group. And the work group met over the course of about 16 months. We had 42 representatives from 33 different organizations. They included public utilities, research organizations, universities, government agencies, advocacy organizations, consulting firms. So it was a broad spectrum on both the water and the energy side. And during our conference call meetings, we had a number of presentations on what water and energy research had been conducted to date. And that research was collected and summarized. And we put a lot of that research in an online database, which Lorraine will talk about in a second. We published the white paper to present the recommendations in June of 2013 on all of these research issues. And all of this is posted on our AWE website. The link that you see down below here is the link for the Water Energy Research Workgroup. You'll get to see all of the 13 presentations. They're all posted, as well as the research summary database and the white paper, which now I'm going to turn it over to Lorraine, and she's going to tell you all about it.
Okay, Marianne, thank you very much. Now, just a bit of background about myself. I used to work for the California Energy Commission and had participated in a lot of the work that the Commission was embarked on to address initially water constraints for power plant usage. In California, there's a significant demand, especially at the local level, for water resources to support all of the energy-related development that we need to provide the energy resources to basically drive our economy. And if you remember from the pie chart that Marianne featured, that 49% of water withdrawals, that's a national number. In California, it's not quite that large, but it is still quite a significant number. What we found is, especially in the desert Southwest, where you see a lot of the energy demand, if you wanted to actually locate the generation close to that demand, you had constraints when it came to water. There were not a lot of supplies to choose from. We developed at the Energy Commission back in 2003 several policy recommendations to try and help rectify some of those issues, but realized there was a lot of research that was still needed, a lot of work on collaborative management that was needed in order to address some of the policy and program issues, as well as just the demand issues of energy resources. Subsequent to that work, the Energy Commission embarked upon the work that's related to the other diagram earlier in the presentation on the water demand associated with the, the energy demand associated with the water-related infrastructure we depend upon. And what we realized is that in California, that demand accounted for about 19% of the overall energy demand on the electricity side used to fuel their economy. That's a significant portion of the energy going towards the capture, treatment, use, and disposal of a particular resource. And we found that if we didn't approach this from a mutually beneficial management strategy, we may actually start instituting programs and policies and requirements that could exacerbate the management of the separate resources. So again, we found that in order to better manage these resources together, a lot of barriers and silos had to be taken down, and a lot of sharing of information was needed so that each sector could appreciate the requirements of the other sector. In the process, those 5 bulleted recommendations that came out of the blueprint really hit home on some of the key elements in establishing the framework necessary to facilitate that collaborative and mutual resource management. In particular, understanding the baseline. What are the minimum requirements? Where are opportunities for efficiency? What types of things would facilitate the better evaluations of even best management practices? What kind of methodologies would be needed so that the different resource managers could actually do their job more efficiently and effectively for the benefit of both resources, energy and water? So in trying to compile this database, we realized that we wanted to address information that is publicly available and non-confidential, things that are already out in the public domain. And the reason for this is many local agencies don't have the resources to pay for some of these more pricey studies. But we also found that by doing so, we realized so much information is already in the public domain that could be immediately put to good use. The other thing that we wanted to be able to do is to focus on both sides of the research question. We wanted to look at research that's done on addressing the water demand of the energy sector, as well as the energy demand of the water sector. So when you looked at the two sides of this coin, it was surprising to us just how much research was really out there. And these are studies we identified through internet searches, going to some of the national lab sites, a few university sites. It was certainly not an exhaustive effort. It was done over a few months. We know that there is much more research out there, but we were able to compile well over 200 documents in this effort. And in doing so, we were able to focus primarily on primary research, so it was not a lot of compiled summaries of other people's work, but this is primary research, stuff that people were going out and doing to answer particular questions, all of which we found was extremely valuable. So to facilitate the use of the database, we wanted to make sure that it contained sufficient information so that anyone looking at these summaries could then themselves go out and find the resources. So of course we've got all your basics, paper title, author, keywords, and some summary of what was done, and of course the pertinent findings or recommendations that came out of the work. Next. So this is what the database looks like. And as you can see, we wanted to make sure it had a date stamp on the title so that folks know what vintage this is. The intent is, of course, with appropriate funding, this will be updated on a regular basis. But the goal here is to ensure that the work that's already been done is accessible to many and disseminated to even more. The idea there being that we want to be able to take what limited resources are out there and direct them to work that has yet to be done. We did find some duplication of effort, partly because we figured that folks didn't always know some of the other studies were either already done or simultaneously being done. So that information is contained in there. We did want to provide as much information on what came out of this work as possible. So obviously that, of course, is the focus and the largest part of the information conveyed in the database. We also wanted to make sure that folks could then link directly from that database to those papers, so a lot of the links are active to the extent that we were capable of doing so. So what we've found is, especially on the energy use of water, some of these studies go back to the early 1970s. And this was, at least from my standpoint, working with power plant licensing, not terribly surprising, because especially since in the early 70s we saw some of the energy crises and the need for building a lot of domestic infrastructure to support growing demand, these kinds of resource conflicts were going to come up. In many instances, you had extremely high usage of water because of what's referred to as once-through cooling. Even when it comes to inland facilities, they tap into water within a river, use it once, and discharge it with very heat-laden and some other contaminants in it. So people were studying things back then to try and address some of those issues. It wasn't until the 2000s, and more recently, I would say even in the last 8 to 10 years, that we really started to see people try and address more of the energy demand of the water sector and trying to make things much more efficient to control cost and to also address other infrastructure constraints associated with getting the energy to where you needed to do some of the water processing and water capture and water delivery. We also found it very interesting that we had not yet found anything that tried to tackle a comprehensive study detailing audits of any kind of embedded energy demand for regional systems. There were some audits done on a particular wastewater treatment facility or a water treatment facility, but nothing on an entire system to look at the interplay between the different components of that system and where the entire system could be optimized. Next, please. Believe it or not, when everything was said and done, we did actually find that there were more studies related to the energy used by the water sector than vice versa. And it was surprising to us the number of studies done recently that really were the cause for tipping this scale. We were interested in seeing this most recent body of work because it was in part triggered by issues of climate change and sustainability and ways of trying to develop strategies to plan for the uncertainties associated with the future, and not just from the standpoint of operations, but also sustainable funding, because energy tends to be the largest cost to the water sector outside of labor. There was a tremendous and obvious need for additional funding for more research because so many of the investigations were asking more questions than they were answering. And so it was, when we look through the database, you'll see some of this. So we published the white paper that summarizes our findings in June of 2013. And we were able to also then compile this user-friendly database that allows people to search for the kinds of information that they're in need of. And we also, as a result of this analysis and this compilation, were able to identify gaps in research that, especially considering the limited amount of funding, could be targeted with that limited funding to expand the base of knowledge. Next, please. So the first recommendation, and mind you, there's 13 here, so with the time that we have, I'm going to try and be fairly efficient. I encourage everyone to take a look at the report and take a bit more time with the recommendations than we might have here today. I think it will be very valuable for all who might be interested in this work that we did. But the first recommendation was obviously that we needed to invest in some research that would do these comprehensive studies and to be able to develop guidelines to facilitate the types of audits that would be needed to address more of these regional system-based assessments so that we could optimize systems rather than single components within them. Next, please. The second recommendation tended to get into why we would really want to be doing this work in the first place. Because water is used so heavily by the energy sector, and vice versa, energy is used so heavily by the water sector, we felt that there is a potential, a significant potential, for efficiencies in both sectors as it pertains to the other resource. And we feel that there is a tremendous need for doing technical and economic potential studies on what the level of that efficiency could be and identify that which is economically preferred so that we could lower the overall costs associated with operating these integrated systems. We also felt that we needed to look at, and where possible, eliminate regulatory barriers that prevent representatives and participants in the various sectors and markets from collaborating. Believe it or not, there are constraints in what water agencies and energy utilities can do together on things like marketing efficiency programs. They can't always mingle their funds to do those things together. It's simple things like that to more complicated things like the requirements for interconnecting biogas generated at a wastewater treatment plant with gas pipeline gas. Things like gas quality standards, interconnection standards, the body of analysis that would have to be done by a water agency or a wastewater treatment facility in order to prove that their gas is good enough, so on and so forth. So we believe that there's a lot more work that needs to be done in that area. Next, please. When it comes to energy efficiency or water efficiency, validating the savings is an extremely important activity that occurs after whatever measure has been acted upon or implemented. And we found that there is a tremendous need for an industry-accepted evaluation, measurement, and verification set of protocols to be used for the efficiency programs when those efficiency programs bring together the water and energy sector. Right now, there are some tools, but there are not really any adopted or accepted protocols for doing that EMNV work. And we feel that that's a big goal that could be established and reached in the near term to help facilitate collaborative implementation of programs. Of course, developing the standards and the models and all those things go part and parcel with that. So the recommendation 5 there just is supporting recommendation 4. Now, recommendation 6, getting to landscape equipment efficiency, gets to a topic that's near and dear to my heart. I actually worked on a regulatory proceeding in California trying to set standards and labeling requirements for irrigation control equipment and other devices used in irrigation. But what we found is that there was not a strong enough body of research on which we could reliably set those standards and show that they were cost-effective. So looking at cost-effective analyses, potential studies, and other kinds of things that would facilitate the establishment of defensible and justifiable efficiency standards for landscape irrigation equipment is critical. Next, please. Now, when we're looking at ways to incent water and energy efficiency, pricing has a tremendous amount to do with it. What we learned in the energy sector is pricing can be used as an efficiency measure. But unfortunately, you don't get the same kinds of approaches and or results on the water side. Pricing is done very differently, and the rate structures are quite different between the two sectors. So there needs to be a lot of research on the mechanisms that can be put in place to eliminate the financial disincentives of especially the water efficiency programs and alternative water supply programs in the water sector, and getting that research disseminated and those kinds of mechanisms put in place. When it comes to desalinization, which tends to be in some regions of California and other places in the United States, desalinization tends to be the next marginal resource that would be developed to provide new resources for the water demand. But the costs for that are very high, both economically and environmentally. So research in lowering those costs is critical to getting that technology so it's much more benign, more affordable, and can be practically implemented to meet new demand. When we look at these kinds of water energy efforts, Recommendation 9 tries to get to what the trade-offs are in this collaborative resource management and development rubric, and being able to look at what types of multi-sectorial strategies could be put in place to balance those trade-offs. Because if we need to develop more energy, yes, there's going to be demands on the water sector, but can those demands be met with minimal impact, adverse impact in particular, to still provide for those energy resources? And the same goes for being able to provide the water we need efficiently so that we don't have to keep building more and more of these water-intensive power facilities. Next, please. With Recommendation 10, again, we're getting back to technologies and protocols, because we want to be able to provide flexibility in not only the water that suppliers can offer to their customers, but facilitate customers being able to use a variety of different resources based on what that water is going to be used for. So in particular, not every power plant has to use potable water for cooling. It doesn't make any sense to use highly treated, energy-intensive water just to evaporate it. There are other resources that could be used much more reasonably and much more practically without impacting the highest quality water. So we feel more development, research, and effort needs to go into developing those technologies and protocols. Next, please. The last few recommendations here really touch on a couple of different things. They touch on supply chain issues, they touch on development issues, and in particular here, we want to be able to look at, when we're developing, especially energy resources, are we being responsible in the use and discharge of the water that's used for those purposes? This gets to the issue of avoidance. You don't have to clean up water if you haven't contaminated it in the first place. So are there ways of more appropriately using these resources so as to eliminate the potential for contamination through either leakages or discharge. In terms of the supply chain question, we want to be able to inform customers more at the end-use stage what the total demand for either water or energy of that end-use product really is. And this particularly gets to the energy intensity of certain water resources. My favorite, of course, is that we use a lot of energy to get water to customers, but that isn't always appreciated by the customers because the cost of the water is so cheap. And we want to be able to get information to customers so that they know what the true cost of the resource is, especially for things like bottled water and or these high-intensive water resources such as desalination, so that they can make better choices when it comes to efficiency. And Marianne, if you'll get to the last slide, we'll go to our final recommendation. We want to be able to continue what the work group and Marianne's efforts started in having this dialogue related to the research and the policy needs, so that we could move more of the positive findings and the good results of this research into the market and be able to see some transformations both in behavior and in market practices. So we're looking for investments in research that help to identify the appropriate methods, practices, and other mechanisms that can be used to support this communication and engagement. Next, please. So this actually is where I'm going to pass it back to Marianne. And I again wanted to encourage everybody to, if you have the time, take a good look at that database. It's got some great work in it. And then also, if you have any questions on the white paper or that database, you're more than welcome to contact me directly.
So what's next? The recommendations that you heard Lorraine describe were drawn from all of the observed findings from the research work that we did, the identified gaps that we found, areas where we felt more constructive work needed to happen. And these recommendations were vetted with the Water and Energy Research Work Group. They had an opportunity to provide input, suggestions, changes, etc. So those recommendations were not just our own project team opinion. They also were vetted with a larger group of interested stakeholders. So we wanted to just make sure you knew that. But in terms of the next steps, what do we do now that we've got this report published? What's next? Well, this webinar is part of what's next. We want to improve awareness of the research issues. We want to try and encourage greater funding of those research gaps. But most importantly, we want to work with both water and energy utilities to achieve better integrated management of water and energy resources. And that is both on the local system level, but also on a regional and national basis. I think we all need a better sense nationally of what the embedded energy value means to the U.S. or the embedded water and energy value, so that we issue our decisions, our policy decisions, with full knowledge of its implications. And what we want to do with this work is to continue to promote it, to perhaps share it with members of Congress who are in a position to provide funding, work with representatives from the Department of Energy to perhaps integrate more of these recommendations into their research agenda. And so we would like to continue the Water and Energy Work Group at least for a few more meetings to do some sort of next step evaluation discussions and figure out how we can more progressively move this issue forward. And this is just a quote that I stole from one of Lorraine's presentations because it seemed to be particularly apt for this particular webinar. Anyone who can solve the problems of water will be worthy of 2 Nobel Prizes, one for peace and one for science. And of course, this is a quote attributed to John F. Kennedy, said during his term of office. And, you know, surprisingly, we haven't made significant progress toward resolution of a lot of those water issues, and now, of course, is water and energy as well. So what we would like to do in closing, we'd like to have now an opportunity for you to ask some questions. Hopefully you've typed them in along the way and Jeffrey can read some to us. Just by way of logistics, I want to let you know that there will be a PDF of this presentation posted on our website, as well as the recorded webinar. If the recording came through all right, we'll post both online on our website. And of course the research white paper and the database summary that Lorraine described are already posted online. That's the URL given there is the shortcut URL for our website. You can also just type allianceforwaterefficiency.org, all one word. And it's right from the home page. It's one of our homepage stories, so you can access both the white paper and the database summary from the home page of our website. And as I mentioned, we're going to do part 2 of this water and energy discussion. We will have a second webinar likely in October, and this will address the best examples that we've found of the Water-Energy Nexus in terms of program implementation. And this is again a project we've done in cooperation with AC Tripoli, and they manage this particular process. And there were awards that we gave for best examples of these combined programs in a variety of sectors, both utility management and commercial and industrial, energy and water efficiency, residential, multifamily, a series of categories. And we will be featuring some of those award winner program examples in the next webinar. So we go from this webinar of theory and research into one that's more practically oriented in an October webinar. So at this point, I'd like to just ask Jeffrey if we've gotten any questions from our attendees.
Thanks, Marianne. Yeah, we actually have a few, and another just popping in. So I can definitely read the first one here if you're ready. Mm-hmm. Just in order of receipt, this one asked early on, why are water energy-based processes not closed loop? Why is water used by one community, dumped back into a river after treatment for another community to use downstream, and so on?
Well, Lorraine, if you want to tackle the energy loop issue, I'll tackle the water loop issue. One of the reasons it's not closed loop and why it's discharged downstream is that there is an effluent requirement that there be a discharge for stream flow purposes. Often a receiving body for that discharge has minimum stream flow requirements that depend on that discharge coming through. So since water is often withdrawn from a river and then returned to the river, that's part of the effluent requirement. Now, your closed loop question implies that we could take the water once, hold it, and then continue to circulate it and never withdraw again. That's not practically possible because usually the drinking water treatment intake and then the wastewater discharge are in different places, not even connected facilities. There are very few water utilities in the country that have both combined drinking water and wastewater. So where they can be productively combined, that would be one thing, but often they are completely separate districts, separate systems, and not even geographically located. They're connected through the distribution pipe network, but otherwise they're not connected together. Lorraine, you want to tackle the energy one?
Yeah. There's a variety of different system designs, and early on the once-through cooling process, where it was basically use the water once and then discharge, was the easiest design to construct. So that was prevalent early on and is still used to some degree in existing facilities, particularly the older ones and the ones along the coast. As some of these facilities are being retrofitted and upgraded, they are going to closed-loop systems. But keep in mind, some of these closed-loop systems still have to have a discharge because they don't have the proper discharge management systems put in place. The work I mentioned that the Energy Commission did to try and address the water use of energy facilities has a policy associated with it that recommends something called zero liquid discharge. What this does is it takes the effluent and captures the water associated with that effluent for maximal reuse within the power plant, leaving behind the impurities in that water as more of a salt cake or a solid. So your salts and some of your metals that would be otherwise dissolved within that water are extracted. So technology is moving into a closed-loop system approach, even more aggressively going into a zero-liquid, complete closed-loop system approach. But what that means, though, is the water is consumed versus just diverted, used once, and put back into the system. So the difference between just diverting the water and using it and then discharging it for additional uses downstream versus capturing in a closed-loop system, evaporating off, conveying all that waste heat in that evaporative water, and then using that water fully, in some communities actually results in a loss to the system of that water. So another one of those trade-offs that have to be evaluated going forward on what's the best way to use the water in that system. Jeffrey, if you'd like to go to the next question.
Great, thanks. Next question is, can you give a sense of how frequently you will update the database summary and or how you will identify new candidates for inclusion?
Well, that's a good question because our funding for this particular project is now spent, and we don't have any funding to continue to do updates, at least not at this point in time, although I'm hunting up interest in continuing this work. But at this moment in time, we don't have an active update schedule planned until we try to secure some additional funding to keep this process going.
Okay, great, thanks. Is there any research being done internationally around the Water-Energy Nexus?
I'll let Lorraine talk about what's in the database, but in our work group discussions, we did have presentations from Australia. Australia's been doing a lot of work in this area, so we did have Steve Kenway from the University of Queensland do a presentation to the group, and that's posted on our website. And I know that our research database was primarily U.S., although I'm sure Lorraine did run across some examples in other countries.
Yes, we actually found there were lots of research projects done in Europe, parts of Africa, as Marianne mentioned, Australia and other parts of the world. We did want to focus on the research that was being done in the United States because what we recognized is the systems do have differences. And this first database compilation we wanted to ensure had the most applicability to the way that the systems are run in the U.S. as possible. Now, we did include some of the Australia work because they have systems that are similar to ours. They have programs that are similar to ours. And so there are things that are quite transferable. In future updates, we hope to expand the body of work to include some of these other studies that have been done abroad and really make the connection between their findings and how that information can apply to the U.S.
So we're seeking funding for this work. We really want to continue it. It's very important.
It is, and certainly is.
Thank you. Next question is, have there been efforts to improve collaboration with and between entities such as CEE, Energy Star, and WaterSense?
The big goal of why the Alliance for Water Efficiency is involved in this effort is to do just that. What we'd like to do is make sure that there's greater collaboration between all of these different efforts. CEE, which is Consortium for Energy Efficiency, has always coordinated with the water community in terms of its appliance tiers for clothes washers and its commercial kitchen initiative. Those were projects that we did with them early on to try and explore the energy and the water connections. We clearly need to do more of that and to do it on a more dedicated basis. We are very involved in the WaterSense program. WaterSense and Energy Star are partner labels coming out of EPA, and they coordinate with each other. Although I'd love to see a lot more attention paid to water in combined initiatives and more funding, especially more funding for the WaterSense program. Today EPA announced, as an example, they announced the Energy Star Building Challenge and competition for buildings across the country. And it would be nice if water had been part of that. So it would be a water and energy building challenge and not just an Energy Star energy efficiency challenge. So these are the kinds of collaborations that still aren't happening. They're largely a function of not lack of desire, but lack of funding. The WaterSense program is an extremely small, underfunded program, and we are working actively to help them perhaps get some more funding so that they can do more collaborative work together with Energy Star.
Great, thank you. A question regarding when you're talking about vetted energy, I believe it was, is it 0.0037 kilowatts per gallon as vetted with NREL? Does that make sense?
You want to take that one, Lorraine? That must be an
the NREL study?
Yeah, I'm pretty sure it's a conversion, NREL conversion to kilowatts per gallon.
Ah, yeah, okay. So what I think the best way to put this is when you're looking at the different studies that have been done, especially on the water associated with, or pardon me, the energy associated with the water, it's important to know what the scope of the studies were. In some of the work that NREL has done, as well as some of the other researchers, the quality of the data is always an issue that they raise. The granularity of the data and the extent of the data that they have had to use. On some of the national studies, the granularity is not that good. In particular, it's because we don't normally track a lot of the energy data sufficient to get those really sharp numbers. So you will actually see some variability in what per gallon kilowatt usage is reported as. It also is very important to understand the system that was studied to generate that number. As Marianne correctly mentioned, in looking at that one diagram from source to source, the variability in that per gallon or per gallon of wastewater energy demand very much is dependent on how that system is designed, what the source of the water is it groundwater, is it desalinization, is it a surface water body, and how much that system operates by gravity. Are there any opportunities for the system to recapture some of the energy that has to be put into it? So we are trying to look at the studies that have been done to get a good sense of how those numbers have been generated and what those numbers really mean, because there is quite a bit of variability, whether it's at the million-gallon level or at the gallon level.
Great, thank you very much. Next question is, do you have any specific recommendations or next steps in relation to the Water Energy Working Group, networking, and sharing of ongoing activities, including pilot studies and joint interest in grant research proposals?
As I mentioned earlier, we would love to continue the water and energy research work groups meetings. They have been meeting pretty much every 6 to 8 weeks, and as I said, the funding for this has now disappeared. But we'd like to continue to do at least a few more meetings, and those would be very appropriate topics to share, particularly as RFPs are issued for studies or or funding proposals are being discussed, this would be a good thing to discuss as a group. And there are other presentations that people have indicated an interest in presenting. So work clearly is continuing, and this is a great forum for sharing that information. We've had it be open, so we are going to have at least 2 or 3 more meetings at the very least, even though we aren't funded, we're going to do that much more. And if anyone on the webinar would like to be part of the group, just send us an email. You can send it to Marianne at a4we.org. Marianne is all one word, M-A-R-Y-A-N-N. And we would be happy to add you to the list and to include you in the next several meetings that we have.
Great, thank you. Last question I have here is, laundry, dishwashing, and toilets are the biggest waste of drinking water by the consumer. Is there money available for disruptive technologies that can eliminate water usages in these areas?
That can eliminate water use in those areas?
Yes, that's what it says.
Well, we have been spending a fair amount of time to reduce the water consumption of all of those fixtures. And the residential end use studies that have been conducted beginning in 1999 and now being more recently updated in 2012 and 13 are showing tremendous reductions in those 3 product uses of water. We've made terrific technological advances in clothes washers and reducing the water factor, the amount of water used per cubic foot of clothing washed in a cycle, the amount of water flushed in each toilet flushing, the volume per minute flow of shower heads and faucets. All of that has been reduced to the point where indoor flow is now minimal enough that gray water is becoming not even a cost-effective option to consider because there's not enough indoor flow to do that with. So I suspect that on the indoor side we've made enough terrific enhancements, especially when you see the residential end uses study published. You'll see terrific drops in per capita consumption as a result of the improvements in technology in those fixtures. The big question is how we can improve those numbers on the outdoor side. We have not experienced the same uniform sets of reductions in outdoor water use, and that's one of the reasons why we have a recommendation in this study is to ratchet down and really understand where landscape irrigation equipment produces reductions in water use that can be measurable and quantifiable in the field. Through studies, we'd like to be able to provide better research on that so that we can also guide technological and product development in irrigation technology. So that's all changing. There's terrific research that's being done there and incentivizing that's happening in the part of water districts and utilities around the country. And that's probably the place where we can make a productive decrease. Some areas of the country, outdoor water use is as much as 70 to 80% of residential water use. So this is a big area that we need to focus on.
Thanks, Marianne. There are no further questions.
Well, great. Thank you all very much for your great questions and for hanging with us to the end of this webinar. We look forward to having you join us for the second one in October, where we'll give some great examples of where water and energy have been productively co-managed. And we thank you once again for attending. I want to thank